day 4 has us working with right trapezoids. But again, before we jump into that, I want to give you guys a practice proof. So we're going to do parallel lines 3. So it's easy, not too bad. So see what you guys can come up with. Again, try to keep in mind what we talked about, sort of these battle plans here. Start with the given, end with the prove. The given may become evidence later. Know your shapes and definitions. If you have parallel lines, look for angle relationships. If you have angle relationships, look for parallel lines. And if you're doing triangle congruence, look for CP, CTC, etc. So, all right, so hopefully you guys can get a start on this and see kind of what you can do here. Here's your statements. Again, if you want to pause and open it and do this one on your own, that'd be great. So I think I'm going to start with K is parallel to P. And I'm trying to prove angle 1 and angle 3 are congruent. So I'll start here. And again, now I have my reasons. So you should be able to match up your statements with your reasons and put them in the correct order. So this one would be given. So now what can I say here? If I know that these lines are parallel. Well, parallel lines, I should be able to say angle 1 and angle 2 are congruent, right? I know that angle 1 and angle 2 are congruent because if lines are parallel, then corresponding angles are congruent. And then now, look what kind of angles are 2 and 3. And by the way, I want to point something out here. I could have said angle 2 and 3 before I said angle 1 and 2 because these are going to be vertical angles, and vertical angles are congruent as well. But again, I like to go in order. I was talking about parallel lines, so I'm going to use those parallel lines. I use, what I did is part of it here. So angle 2 and 3 are going to be vertical. And then, hey, look, if 1 is 2 and 2 is 3, then I guess 1 is 3, and that's transitive. So let's see how we did there. Looks good. We did a good job, so we're happy with that. All right, so if we go back over here, again, we're going to do 2 different proofs today, and we're going to do it a little bit differently in the sense that I'm giving you the picture, and I'm telling you what I want you to prove, that MNOP is a trapezoid, and I'm asking you to fill in as much of this proof as you can without any help. So if you'd pause the video, I think that would be great, and just see how much of this you can figure out with no help. Again, though, I would tell you, you do have some help. You guys have this to sort of go in order, and then you have, I don't know what I just clicked there. You have this to sort of help us go through that, right? You have your shapes, and then you have your vocabulary of different things that we've talked about. So we'll go back over here. Again, I'll pause, give you a minute, and see what you come up with. Okay, so hopefully you're unpausing this video and are going to check your answers. So I'm going to go through in order. The first thing, start with the given and end with the proof. So I can start filling this in already. I know that angle M and angle P equal 90 degrees. Angle M and angle P equal 90 degrees. I know that because it's given. And I know I want to M by saying MNOP is a trapezoid. Here's the problem, though. I'm still sort of going through here. I don't know. Now I'll look for step 2. The given may become evidence later in the proof. So let's take a look here. Does that help me at all? It's given that these are 90 degrees. Am I going to say something as 90 degrees? I'm not sure that that's going to... It's not like they're saying, hey, these are perpendicular, and then I'm using that later, right? They're saying these are 90 degrees. That's not super helpful. So I don't think I'm really going to be able to make use of the given may become evidence later. Know your shapes and definitions is going to be a really big one here. I need to prove something is a trapezoid, but I have no idea what a trapezoid is. So I'm going to go here and look. A trapezoid is a quadrilateral with at least one pair of parallel sides. So it looks like I'm going to need to prove that MN and OP are parallel. I hope we can all agree to that. And a matter of fact, that's probably what I'm going to prove right here, right? MN is parallel to OP. I'm going to have to prove that that's true. So, and then I can say that they're a trapezoid because that's the definition of a trapezoid. Hey, look, I proved these lines are parallel, so that means that this shape is a trapezoid. So I know all of my facts. Now I just need to have to give some evidence, right? See if I can get a little bit more help going through this plan here. Parallel lines and angle relationships. I must be looking for some angle relationships. So what angle relationship is going to help me over here? I have alternate interior, corresponding, reflexive, vertical. I don't think any of those are going to help me, which is a bummer. So I must have one of these left off, and hopefully you guys know what that is, so we'll see. So M plus P equals 180. Well, 90 plus 90 is 180. I think that's the additive, right? So we'll just say addition here. If you want to, you can say the additive property of equality. Addition property of equality. I basically added those up. And hey, look, now I can say these lines are parallel because the same side supplementary angles. So if same side interior angles equal 180 degrees. So you guys might remember that from way back earlier in the year, but we said, hey, look, if these same side interior angles don't add up to 180 degrees, they're not parallel lines. But if they do add up to 180 degrees, then we have parallel lines. So if same side interior angles equal 180 degrees, we can say those lines are parallel. 90 plus 90 is 180. Hey, look, these lines are parallel because same side interior angles add up to 180. And if these lines are parallel, then I'm looking at a trapezoid. So kind of an interesting one. And again, if you didn't fill in 1, 2, 3, 4, 5 of these spots, you should have easily been able to fill in this one. You should have easily been able to fill in this one. This one, I don't know how easy that would have been, but I definitely think you could have got that. These two were going to be tough no matter what. But look, if you're going partial credit, you got 3 out of 5, which isn't bad at all. All right, let me pause and set up the next one. Next proof, normally I don't like to give any hints on this one, this is a really difficult one, but that's fine. I just want to see how far you can get. And again, the expectation isn't necessarily that you fill the whole thing in, but that we use this plan to become comfortable with filling in as much of this as we possibly can. So that's really the goal here. So again, I would say kind of look through these steps, pause the video, get as far as you can in proving this QRST is a parallelogram, and see what you can come up with. I will give you one hint. It is, you can do it in 4 steps. You may do it in longer, but you can do this in 4 steps. Alrighty. So here's where I think we should start. Angle Q, again, hopefully you've already paused the video. Angle R, angle S, and angle T equal 90 degrees. That's given. And we don't know step 2, we don't know step 3, but we do know that step 4 is going to say QRST is a parallelogram. So that's how far we get just from step 1, right? We started with the given and we end with the proof. Now the given may become evidence later in the proof, so let's take a look here. The fact that these add up to 90, I don't think I'm going to say anything like equals 90 or whatever, so that's probably not going to be what it is. Know your shapes and definitions of those shapes. So yeah, I think for sure this is going to be super helpful, right? I know I need to prove something as a parallelogram. We've already done parallelograms, but hopefully you remember parallelograms have 2 pairs of parallel sides. So that means that I'm going to need to say that QR is parallel to TS, and I need to say QT is parallel to RS. Because I'm not going to be able to do that unless, right, I'm not going to be able to say that's a parallelogram unless I've done this, so that's going to be definition of a parallelogram. Once I have proven these opposite sides are parallel, then I'm going to be able to call this thing a parallelogram because of the definition of a parallelogram. So I can fill that much in. And again, parallel lines, angles, yeah, I definitely think that this has something to do with it, but just like in the last one, maybe we need to add this, right? Maybe we need to add same side interior, because same side interior isn't popping up here, which is kind of a bummer, but parallelogram definitely is. So, and then triangle congruence, there's going to be no triangle congruence. But look, I filled in 5 of the 8 just from using my law. I haven't even really looked at the proof yet, right? But I know that I have to prove these lines are parallel, so that if I prove these lines are parallel, that's the only way I can say this is a parallelogram, is if I prove that these opposite sides are parallel. And that's going to allow me to use the definition of parallelogram. So now I just need to fill in the rest of it. So again, just the idea that we have this plan that we use, right? If we use this plan every single time, we can begin to fill in a bunch of the proof already, and then we just try and see, okay, what's left? Well, hey, look, just because we just did the last proof and it's in my memory, what if I say angle Q plus angle T equals 180 degrees, and if I say angle Q plus angle R equals 180 degrees. So I know that this is, let me pause real quick. Q plus angle T, we know that equals 180, and angle Q plus angle R, we know that equals 180. So that's setting us up for these same side interior angles, but we're just going to say again that this is the addition property of equality. All right, so angle Q is parallel to angle TS, and angle QT is parallel to angle RS. Well, that's same side interior angles, right? So if same side interior angles equal 180 degrees, then lines are parallel. So there we go. And you can see how much this we can fill in just by using that one plan. And again, just that repetitive, use the plan, use the plan, use the plan, see how far we can get, fill in the rest.